Hi, Assalamualaikum. Today we want to present our project which is 2D and 3D excavator. Let's jump to know our team member. We have 4 members. The first one is Farhana. The second one is Mohamin, which is me, and we have Hazim and Intan. Let's go to see our project.
Assalamualaikum, my name is Farhana Damia binti Muhammad Khairi. So I would like to continue about our group project, which is a 2D excavator simulation using OpenGL. So first of all, looking at the environment, all objects like trees, cloud and the machine are built using basic primitive. So we created a custom function like draw rect and draw circle, then combine the shape to build a complete object. So let's move to the technical part. First is a translation. When I press A and D, the excavator moves to the left and right. The coding logic is simple. We use the GL translate F function on the x-axis and the move x values change based on the keyboard input, moving the entire machine across the screen. So next is a rotation. To move the arm up or down, so we use a GL rotate F. When I press Q or E, the arm angle change. This function allows the arm to rotate around the specific pivot point, making it look like a real hydraulic joint. Now this is the most important part. Notice that when the arm moves, the bucket moves with it. So but at the same time, the bucket can also rotate on its own. We call this hierarchically modeling. So in the code, we use GL push matrix and GL pop matrix. Basically, the arm is the parent and the bucket is the child. So the parent's movement affect the child, making the digging simulation looks realistic. Finally, we also implemented the scaling. By pressing the plus or minus button, we can zoom in or zoom out using a GL scale F. So in conclusion, this project successfully combines translation, rotation and scaling to create an interactive 2D animation. So that's all from me. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Kasara binti Sarani. So, today I will explain the code for our 2D excavator project. First, the libraries. We include OpenGL for graphic, Math for calculation and standard library. The variable at the top, we have 4 main variable, which is move x for left-right movement, arm angle for arm rotation, bucket angle for bucket tile, and zoom scale for zooming. The drawing function, we make helper function to draw shape. Firstly, we use draw rect to make rectangle, draw circle to make circle using math calculation, draw cloud combine circle to make clouds, and draw tree for make trees. The environment function, draw environment, create the scenes which is blue sky, green grass, many cloud and trees. This draw first, so the excavator appears on top. The main display function, this is the most important part. It clear the screen. It clear the screen. Apply zoom, draw the environment, then draw the excavator. So the excavator has several parts, which is track and wheel at the bottom, yellow main body, grey cabin with blue window, and rotating arm and tilting bucket. So we use GL translate to move, GL rotation to rotate part, and GL scale for zoom. GL push matrix and GL pop matrix help separate transformation, so part move independently. So for keyboard control, the keyboard function check which key is pressed and update the variable. For example, alphabet A decrease move X, alphabet D increase it. The glued post redisplay redraws everything. For main function, this set up the window, projection and start the program loop. That's the basic structure of our code. Each key press, change variable and the display function redraws everything with the new position. So that's all from me. Thank you.
So let's talk about the design of the excavator model. The excavator model is designed to look like a real hydraulic excavator that used at a construction and mining site. So the main purpose of the designed to practice hard surface modeling and learn how machine parts are connected in 3D. So the model includes important parts such as the track, cabin, boom, arm and bucket. So the track help the excavator to move on the ground, on a rough ground that were made using repeated shapes to keep both sides even. And the cabin was modeled by the simple box shape but with slightly rounded edge to look more realistic. So the boom arm and buckets were created separated to show the real movement and allow future animation. And basic shapes tools in Blender such as extrude, mirror, scale were used during modeling. And also the simple color were added to the excavator model such as yellow and dark color. The yellow is used to the main body of the excavator to look because it's more recognizable in the construction site. And also the dark color for the tracks. Along with basic lighting, also we use carbon fiber to match the material of the model. So the excavator was placed in a rocky environment to make the scene more realistic.
The individual metal plates are called shoes or links. They are joined together by pins to create a flexible change. The smooth wheel at the front, it doesn't have power, it just guides the track and keep it tight. The excavator laying its own road is the coolest way to describe. This is the tracks then actually slide. The track lays flat on the ground and the wheels roll over the track like a temporary road. To make the movement realistic, I set up a mathematical driver. This links to forward motion of the chassis to the rotation of the wheels. This means that when I move the excavator forward or backward, the tracks rotate at the exact correct speed, preventing any sliding effect on the terrain. Finally, I placed the model in a rocky desert terrain to test how the lightning interacts with the glossy surface.